This is London's Crossness pumping station. Its gorgeous architecture and intricate ironwork conceal its original, somewhat revolting purpose: to transport raw sewage from London's southern outfall, the lowest point of one of the city's largest sewers, to the ground surface, where it could be discharged straight into the Thames River. Of course, we no longer discharge raw sewage into bodies of water, and since the 1950s, when newer treatment plants were created, Crossness has been decommissioned. It is currently being restored as a museum where you can learn more about the intriguing history of human waste and Victorian engineering. Even while we now have more advanced methods for treating wastewater before dumping it into streams and rivers, one thing hasn't changed. We still rely on gravity to transport waste away from houses and businesses into underground sewers. And eventually, we'll need a mechanism to return that sewage to the Earth's surface. But it's not as simple as it appears. Don't forget to hit the like and subscribe button to get the latest videos. Most of the sewers flow from each home or business to a wastewater treatment plant by gravity. Although sewers are placed as pipes, they normally only flow partially full, like stinking water slides or underground creeks and rivers. We don't have to pay a monthly gravity bill, and it's nearly never knocked out, which is convenient. When there's a thunderstorm, it's a constant and unrestricted force that pushes sewage downward. However, because gravity only pulls in one direction, sewers must always slope, which means they frequently end up deep below ground level, particularly near their downstream ends, which can be troublesome. Therefore, sewers are nearly always placed in trenches or open excavations. This may seem self-evident, but the deeper a trench must be dug, the more time it will take. The more difficult, dangerous, disruptive, and ultimately costly work becomes, it may become impossible to pursue the slope of a sewer further below the Earth's surface in some situations. Installing a pumping station that can lift raw sewage from its depths and bring it closer to the surface is a suitable solution. Lift stations can range in size from tiny facilities meant to serve a few apartment complexes to large capital projects pumping considerable amounts of the city's entire wastewater flow. A basic lift station consists of a wet well, which is a concrete chamber into which sewage runs as gravity fills it over time. When the sewage has reached a certain depth, a pump is turned on. It pushes wastewater into a specialized sewer pipe known as a force main. This means that you want to keep the liquid moving as quickly as possible through the pipes to avoid solids settling out. As a result, this intermittent functioning ensures that no slow trickles occur during off-peak hours. Within the force main, sewage flows under pressure to an uphill manhole where it can resume its downward journey via gravity. The end of the line is another key place for lift stations. There are no mystical underground sewage outlets once wastewater reaches its destination. Septic systems get rid of wastewater through leach fields that infiltrate the subsurface, but they're designed for individual buildings and aren't feasible on a city scale because getting so much liquid to soak into the soil would require vast swaths of land, not to mention the risk of groundwater contamination. We still need somewhere for our sewage to go, ignoring the fact that we need to clean it up first. In most situations, this is a creek, river, or ocean, implying that we must once again lift the sewage to the Earth's surface. Rather than lovely, stinking superheroes, construct wastewater treatment plants and underground levels, so we only pump clean water. It's far more convenient to just lift raw sewage to the surface, where it can be treated and subsequently discharged. That means we'll have to transport some pretty filthy sewage through some fairly expensive and sophisticated technology. The pumps, which will present some difficulties. We commonly associate sewage with its most odious constituents, human excrement or poop, but sewage is a slurry of liquids and solids originating from a wide range of sources. Soil, soap, hair, food wipes, grease, and trash are among the items that wind up in our wastewater system. These items may make their way down the toilet or sink drain, as well as through your home's plumbing. However, in the sewer system, they can clump together into enormous balls of grease rags and other debris, which wastewater professionals refer to as pigtails or fatbergs. Furthermore, with many cities focusing on water conservation, particulates and wastewater concentrations are increasing. Pumps are good with liquids, but adding particulates to the stream makes lifting raw sewage more difficult. With this demonstration I set up in my garage, I'll show you what I mean. This is a small submersible pump for draining water from basements or swimming pools. It's basically an electric motor with a small impeller inside a molded plastic shell that I removed from the screen so we could see how much power it had. Clear water is easily moved by the submersible pump. Toilet paper is no problem for the little pump. It can easily tear apart the paper. Small, suspended solids, such as these plastic balls, can be handled since the particles stay in solution, generating a slurry comparable to raw sewage. Larger particulates in this stream, on the other hand, might quickly clog the pump. Anything larger than the impeller's gaps will simply not pass through, and clogging becomes a serious issue with stringing debris. These are flushable wipes, unquote. These wipes may make it past a toilet, but it's easy to understand why they're an issue in a wastewater stream. I'm not in the mood to pour a bunch of grease in my presentation, but I'm sure you can see how congealed fats and oils would further worsen the problem of blocking this pump. It's obvious that centrifugal pumps of the right size can handle specific types and sizes of suspended particles. Just excellent sewage pumps are built to withstand the increased wear and tear. The impellers have fewer vanes to avoid snags, and the ports are bigger to allow solids to flow freely. Different manufacturers have specialized designs to minimize blockages to the greatest extent feasible, but no sewage pump is impervious to clogging, especially with today's concentrated effluent containing flushable wipes. Clogs and lift stations can happen on a regular basis. Removing a pump, cleaning it, and reinstalling it is a messy and expensive job, especially if it must be done frequently. When the level rises too high, most lift stations sound an alert. However, if a clog is not cleaned quickly enough, raw sewage can back up into homes and businesses or overflow the wet well, posing a biohazard to humans and wildlife. The use of a screen in the lift station well to prevent the trash from reaching the pumps appears to be an obvious solution to the problem of clogging. But screens have a limit to how much debris they can clog up to. By adding a screen, you've traded pump maintenance for another kind of maintenance, removing and hauling away debris. Smaller lift stations with the bar or basket greens may be able to get away with personnel cleaning them once a week. Automatic systems that filter sediments from the screen into a dumpster that can be carried to a landfill on a regular basis are common in larger pump stations. Although employing a screen to prevent clogging is sometimes useful, it is not always practical, especially because it generates a distinct waste stream to manage. If a lift station is in a remote location where sending employees for repair and maintenance is inconvenient, you may prefer that all solids remain in the wastewater street. After all, treatment plants are constructed expressly to clean wastewater, and they have superior equipment and constant staffing, so it frequently makes more sense to focus time and effort at the plant rather than at individual lift stations along the way. There is another way for preventing pump blockages in certain situations. The solids are ground into smaller pieces. A lift station grinder has a lovely counterpart that may be found under the sinks of many North American homes. Garbage disposal is common domestic equipment that eliminates the hassle and odor of placing food leftovers in the trash can. It has a rotating impeller and works similarly to a centrifugal pump, but it also has a grinding ring with sharp blades and small apertures. The materials scrape against the grinding ring while the impeller spins, breaking them into smaller pieces that can pass through the waste piping. All the solids are handled by my garbage disposal. With the submersible pump, I had no problems with clogging. It struggled with the wipes, but it was still able to chew them up. Some lift stations include grinding pumps that look eerily similar to garbage disposals under the sink. Others employ standalone grinders to chew up solids before they reach the pumps. Grinder machines are frequently used in medical facilities and jails where fibrous materials are more likely to enter the wastewater stream. Large grinders are also used where storm drains and sewers are combined because those systems see heavier debris loads from the rainwater runoff. A grinder is an additional costly piece of equipment to purchase and maintain at a lift station, but it can provide better reliability, fewer clogs, and thus lower maintenance costs. Of course, clogging isn't the only issue that arises when operating a sewage lift station. When you rely on electromechanical equipment to perform a critical function, you must constantly prepare for the worst. Multiple pumps are frequently installed in these stations so that they can continue to operate even if one fails. They frequently feature backup generators so that sewage can flow even if the grid goes down. Another problem with lift stations is that air bubbles can get into the force mains and restrict flow. Automatic air release valves can clear these bubbles from force mains, but venting sewer gas in inhabited regions isn't always a popular option. Although our urban lifestyles rely on sewers to transport waste away before it might damage public health, they are usually unwelcome reminders that they exist. Hopefully, this video will help you learn a little more about the difficulties and solutions of wastewater management to obtain your city clean and safe. Thank you for watching. Kindly subscribe for new videos.